on May 5th. So let's take a look at it. Okay, so this is an example from the last homework set actually. So you should be able to do this one. So should I ask somebody to do this? I will ask. Who should I ask? Just a second, I'll turn this off. I'll check your names. And I'll ask somebody to do it. Okay. Let's go to here. Okay, I will ask Shanaka. Jayaratne. Okay, so just as I'm only going to ask you to do the first part, let's look at the first part first before you do it. Okay, okay, so here's the example. It says, your college newspaper. Do we have a college newspaper at APU? I heard someone said we did actually. But they don't sell it, it's free. But in this example, they're going to sell the copies of the college newspaper. So your college newspaper has fixed production costs of $76. Okay, do you get that? Fixed production costs of $76. You see this word? Fixed. Okay? Per edition. And marginal printing and distribution costs of 38 cents. Okay? Per copy. And they also tell us one more thing, which we don't need for this part, which is it sells for 48 cents a copy. Okay? Alright, now, they say write down the associated cost function. Write down the associated cost function. So, Shanaka, you can come up and do it. Don't ask somebody else. All right, if you want to, but you should be able to do this yourself without somebody else. No, you don't need his, do you? You can just read it, can't you? I don't need him. Can't you do it yourself? I guess not. Okay, good. All right, now wait, stay up here. Stay up here. We'll have you do one more. Here's the next one. Can you read this? Here, you can read it here. Write down the revenue function in dollars. So what's the revenue function? So he just wrote the cost function, right? You just wrote the cost function, right? So now, write the revenue function. So what do you need for the revenue function? You need to know how much they sell the paper for, right? Then you can know, right? So how much do they sell the paper for? 48 cents. So what's the revenue function? R of X, revenue. No. No? Okay. What's the revenue function? This was from our homework, right? We did this. So what's the revenue function? From the homework. Okay, tell me, wait, just tell me. Don't get nervous. It's very easy. What does revenue mean to you? Yeah, right. How much money I got, right? So how much money do you get? Yeah. How much? No, not this. How much do you get? 48 cents per. Yeah. So if I get 100 or if I get 10 papers? Yeah, right. So what's the function? In terms of the number that we sell. X is the number we sell. So what's the revenue function? times x, right? Yeah, so write it. Right, times x, yeah. Right. Yeah, right. And then give it the name. Give it a name. What's the name of this function? Equals revenue. Just r, okay. Now, I don't like just r because I want to express the fact that r is a function and that r is a function of x, right? I mean, r is okay like that, but it's a little more informative to say what? R, no, leave the r. R of x, right? Why is it r of x again? Because the revenue depends on x, right? That's what r of x means, right? It means the revenue depends on x. Okay? Okay, good. Okay, so thank you. Everybody get that? Okay. Now, how about the profit function? So I'll ask one more. I'll torture. I just tortured Shanaka, right? I just tortured you, right? Torture. Right? I just tortured Shanaka. Now I'll torture one more person. Who gets tortured next? Okay. How about Mile Tilipe Pifta? Are you here? Okay. So you can come up and be tortured also. Oops, sorry. So here, just write down the profit function. So we have the cost function and the profit function. I'm sorry, we have the cost function and the revenue function. So what's the profit? Okay. Yeah. Okay, does everybody agree with that? Everybody agree? It's what? What's the thank you. So what's the formula? Revenue minus cost, right? Okay, good. So you did do your homework. That's good. Okay. So, all right, let's go on. How about this? This is also, here they're telling us a cost function. Now, in the last example, the cost function was linear, right? In the last example, the cost function was linear, right? Linear, what does linear mean? What does linear mean? Linear comes from the word line, right? Why do I call this linear? Why do I call it linear? Because if I graph it, and let's call this side y, so I really have y equals 0.38x plus 76, that's a line, right? Right, so that's called linear. Okay? Now in the next example, the cost function is given here. Is this one also linear? No. Why not? Because it has a square there, right? So it's not linear. Right? So, so it's not going to be a straight line. But that doesn't mean it's not a cost function. Okay? So this is going to be a different cost function. So it's going to have like a parabolic shape, right? If we graphed it. Okay? Now, here's another piece of information. So this is the cost function. By the way, is this, what's the fixed cost here? What's the fixed cost? 2950, right? And then how many terms are there for or what's the variable cost? 6x plus 0.1x squared, right? Okay, so they would have the fixed cost and the variable cost. Okay, now we have another piece of information here. They sell their shoes, these are shoes, at $110 per pair. Find the revenue function. So what's the revenue function? About Shanaka. What's the revenue function? No, don't ask your friend. Just do it. What's the revenue function? It means how much are they selling it for? $110. So what's the revenue function? $110 X, right? Okay. Okay, so it's $110 X for the revenue. And how about the profit? It's going to be $110 X minus the cost function, right? So minus 2950 plus 6X, whatever, right? Okay, so that's going to be the profit function. Any question? Now, one last thing is, oh, I forgot this one. This one's easier, so let's do this one. So she wrote down the profit function here. Right? She wrote down the profit function here. Right? So the question I forgot was here. How many copies should be sold in order to break even? So remember, what does break even mean? So it means we didn't make a profit and we didn't lose any money either. So what does that mean in terms of the profit? Was the profit positive? No. Was the profit negative? No. What does it mean? It means the profit was 0. So how do we find the break-even point in this case? What should I do? Set it equal to 0 and solve, right? Okay, so I won't do that, but it's easy to solve that, right? Just find out what X gives you 0 for this equation, right? That shouldn't be very hard. So that would be called the break-even quantity that needed to be sold. Then you wouldn't make any profit, and you wouldn't lose any profit. And if you sold more than the break-even, then what? You'll have a profit, right? Okay. So they say here, how many should they sell to make a profit? So the answer is going to be something like more than something, right? And at least something, right? And what's the at least going to be? We just need to find the break-even point again. Now in this case, it's not going to be quite as simple because the cost function has a square in it. So this didn't have a square in it, so this should be really easy to solve. The other one is a little bit more algebra to solve it, right? But shouldn't be too hard. Any questions about that? Okay, these are all similar to that. And then finally we get to a new one here. So let's talk about this one now. Oh wait, did I forget something? Yeah, there was one here I wanted to do. Here. Okay, this one. Let's look at this one. So how about this one? So this is a little unusual. Given the following notation, find a formula for the break-even sales level. Okay, now we have to look at this notation. So I see, how many notations do you see there? How many notations do you see there? 3, right? SP, FC, and VC, right? That's 3 notations. Okay, so we have to look at what they mean. So what does SP mean? Selling price per unit. So like in that example that I just wrote down, that we did at the very beginning, what was the selling price per unit? Shanaka, sorry to torture you, but what was the selling price per unit in the last example? In the example you did, the selling price, how much? Right, he's good, I don't know if you're good. Your friend is good, but he doesn't have to, you can do it, right? I'm sure you can do it. So what is it? The selling price per unit is 48, oh, I think it was 48 cents. So that's what SP is, right? Everyone understand what SP is? Okay, now what's the next variable we see there? What's the second variable? FC, right? Okay, so what is FC? What does it say? Total fixed cost, right? Okay, so that's FC. What is total fixed cost means what? How about in one of the examples we had here, what was the fixed cost, or the total fixed cost? 2950, right? That's called the fixed cost. So, okay, in that case, the fixed cost was that. How about, did we do this one? What was the fixed cost here, by the way? $76, right? Okay, so that's what we mean by FC, right? Everyone understand what FC is? The fixed cost. Okay, and then VC. Now, when I did this in class last time, I got mixed up. But anyway, VC is the variable cost. Now, I read it wrong, and I just read variable cost, and not variable cost per unit. So VC. Anyway, what is VC? Like in one of our examples. How about let's go to this one. VC. I think I wrote VC as 48. No, sorry. What's the variable cost here? 38, right? I think I wrote, when I did it before, I did 38x. But that's, I read it wrong, because it's not 38x, just 38. Okay, because it says the variable cost per unit. Okay, a little tricky there. Okay, so it's not 38, it's not 38x, it's 38. Okay, so take that into consideration. And now we're supposed to do what? Write the formula for the break-even point, for the break-even sales amount, so X. So how do we do this? We want to write the profit function using this notation, that's all. Okay, so it shouldn't be that hard to write the profit function using this notation. So the profit function is what? It's the revenue. So how do I, now, but how do I write the revenue function? The selling price is SP, right? So the revenue is SPX, right? SP times X, right? Okay, and then minus the cost, right? So how do I write the cost function? So that is what? The fixed cost, FC, plus VC times X. Right now, I just wrote it as VC when I did it before, but it's VC times X. Okay? So now what do we want? We want to find X when we're at break even, right? We want to write a formula for X when we're at break even. Okay, so how do we do that? We set this equal to 0, which will give us the break even, right? And then we just solve for X. Okay, so how do we get that? We have SPX minus FC plus VCX equals 0. So what do we get? We get, oh, minus, thank you. So what do we get? We can bring the FC to the other side. SPX minus VC, X equals FC, right? So factor out the X, and we get FC over SP minus VC. But I think I did something wrong again. I don't remember. Oh well. Let's check their answer. By the way, this is kind of...
Break-even analysis from a CPA exam, given the which equals...
So did I get the wrong answer or not?
minus VC.
Was that right or wrong? Oh, okay, so this is right. Okay? By the way, this is kind of interesting. This comes from a CPA exam. I was shocked, because this is pretty easy. I mean, this is extremely easy problem. But a CPA exam is like a law, like a law exam for a lawyer. So you get, if you want to practice law, for example, in the United States, you have to go to, in the United States, basically you have to go to 4 years of undergraduate, 3 years of law school, and then you take the law exam, the bar exam it's called, for a particular state. Like if you want to practice in New York, you have to take the New York bar, and take another one, you take a different bar, and then you can practice law there. And this is for to become a certified public accountant, you have to do the same thing. And this CPA exam is supposedly much harder even than the law bar exam. Very hard. But this question is very simple. So, anyway, they say this comes from the CPA exam. Okay. Anyway, I guess it's hard because you have to know about a million things. Maybe they're all not so hard, but you have to know so many of them. Okay, any questions so far? All right, now let's go to this one. Okay, so suppose I'm selling Rolex watches. Okay, so Rolex watches are usually expensive. Cost like $5,000 or more. So now, if the price is really high, am I going to be able to sell a lot of Rolex watches or a little? Just a few, right? But if I can lower the price, then I should be able to sell more, right? So if I start out at $10,000, I probably won't sell too many. But then if I lower the price down to $500, maybe I can get a lot of people to buy them, right? So, okay, on the other hand, if you think about the person who's, so that represents the people who are buying the Rolex watches, actually. I'm talking about if the price is high, they don't want to buy many, but if the price is low, they want to buy a lot. On the other hand, if you think about the people who are selling it, it's just the opposite. When the price is high, suppose we have a lot of people who are selling Rolex watches, a lot of them will go out and try and sell their watches when the price is high, right? But when the price is low, only a few people will. Only the desperate people will, right? It's like in the stock market, right? When a stock is priced very high, only a few people will be interested in buying it. But when the stock is priced very low, everybody might go out and say, "Oh, it's very cheap now, I'm going to buy it," right? So that kind of thing. So, but on the other hand, for the seller, it's just the opposite, isn't it? Right? If the price is really high, the seller will be willing to sell a lot. If the price is low, there won't be many sellers. Right? Does everyone agree? So, if I make this picture, or let me make two pictures. And I'll put P here. Now, in some classes, they reverse P and Q. So just be aware of that. Sometimes, in some finance or economics class, they might reverse P and Q, put P up here and Q down. But anyway, I'll do it like this. So if we do that, and I draw some kind of shape like that, it could be just a straight line, but my point is just that it's decreasing. However you want to draw that, and here, like that, maybe increasing anyway. Okay? Now, which one of these represents the customer's point of view, or the customer's desires? Which one? The right one or the left one? Okay, that's the question. So think about that question. Which one represents the customer's thinking? Okay, so what's the difference between the two? The right one, what happens? As P increases, Q decreases. And the other one, what? As P increases, Q increases. Right? What I'm saying is that one of these represents the buyers, the customers, the consumers, and one of these represents the seller, or the supplier. I'm asking you which one is which. So let's just focus on one of them. Let's just focus on this, the buyer, the customer, the consumer. So which one represents the consumer? So this would say that as P increases, the consumer wants to buy. What's happening to Q? It's getting less, right? So that would say the consumer wants to buy less. And this one would say what? As P increases, the consumer wants to buy more. So which is true, generally speaking? The right one, right? So this one is called the demand curve. That means the consumer demand. How much is demanded by the consumer? So this is called the demand curve, or D. Okay, does that make sense to everybody? Okay, so this is not called the demand curve, right? Because this says what? As the price increases, this would say what? That people want to buy more? That usually doesn't happen, right? Only in a very weird place. There used to be some examples like people kind of crazy, you know, they have so much money, for example, or their money is flowing so much in that country that they want it more if it costs more. There have been examples of that. Like when people suddenly a country starts getting really rich and money is just flowing like crazy, people want to show off. So when it gets more expensive, they want it more. So that's a really, really weird case, right? So we're not really thinking in those situations. Although we have to realize that this doesn't always fit, right? But usually it will. Okay, now on this one then, this generally would represent the supplier, right? In other words, as the price increases, more goods will become available. More Rolex watches will become available. More people will be willing to sell them, right? So this represents the supplier, or S, or the supply curve. Okay, so we have the demand curve and the supply curve. And you should be able to know which one is which. Shouldn't be that hard to figure it out, right? So just remember, like I said, sometimes we'll switch P and Q in some books. Now we won't be doing that, but just in the future, just so you know, some books might switch them. Okay, so everyone gets that, right? Now, what's next about this? We have the supply and the demand. And what do we want to do next? I forgot. So, something I wanted to say about this. Oh, now, suppose that it's really cold in this room and it's really hot outside. Okay? So if the door is shut, then it's going to stay that way, right? It's going to stay cold in here and hot outside. But if I open the door, what's going to happen? The cold air in here is going to go out, and the hot air outside is going to come in, and eventually what's going to happen? The temperatures are going to get equal, right? And in physics, that's called an equilibrium temperature. So we'll say that it will reach an equilibrium state, or an equilibrium temperature, right? That's natural. Okay? All right. Now, all right, so let me go to next thing. So let's go to this picture next. So suppose we put both pictures on the same, in the same axes. So superimpose one on the other. So I do this. I have P and Q, and then I do that. This is the demand curve, and this is the supply curve, right? Now I don't know, we don't know the shapes of these curves, so I just made it. But the point is that one is decreasing and the other is increasing. Okay, now, suppose the price is down here. Is that a high, on this scale, would you call that a high price or a low price? Low price, so let's call it P sub L. Okay, suppose or not quite that low because you won't be able to see what I want to show you. Okay, there. Suppose the price is there. Now, what does this curve mean? The supply curve means that if the price is here, then that's how many we can sell. No, sorry. That's how many the suppliers will want to sell. Right? In other words, when the price is low, the suppliers will be willing to sell this amount, which is not so much, right? On the other hand, when the price is high, maybe up here, then, using the supplier's curve, it's going to be up here, right? They're willing to sell a lot. Right? Does everyone agree? That's what that curve means, right? That's what those curves mean. On the other hand, when the price is low, what's the demand look like? Is it going to be high or low? High, right? And we can see that maybe here, right? It's going to be up there, very high. So when the price is low, there's a lot of demand, but there's not a lot of supply, right? So the demand is high, but the supply is low. Right? Everyone agree? So in that case, when there's a lot of demand, we say there's a shortage. When there's more demand than there is supply, we call that a shortage, right? There's a shortage, there's not enough. Right? So there's a shortage. And how much of a shortage is there? Well, here's the amount that's available, and here's the amount that's being that's being demanded. So it's the difference between these and this. Like suppose this is 1,000, it's being demanded, and this is 100, then there's a shortage of what? 900, right? There's 900 that can't be bought. People want to buy them, but the sellers only are willing to sell 100. Okay? So there's a shortage of 900. In other words, this distance represents the shortage, right? The length of that line is the shortage, right? Everyone agree with that? Okay? Now, how about if the price is here? P2. Then there's still a shortage, right? Because the supply is here and the demand is here, right? So there's still a shortage. How much is the shortage now? It's the length of that line, right? Does everyone agree? Okay? On the other hand, suppose the price is high. Then what's the situation? So here, let's say that was 100. So the demand is the price is so high, there's only a few people that want it. There's only a demand of 100. Okay? On the other hand, the price is really high, so a lot of sellers are willing to sell. So the supply might be like 1,100. Right? Okay? So is there excess demand or is there excess supply? There's excess supply, right? There's more supply than demand, right? And what's the excess? If this is 1,100 and this is 100, the excess supply is 1,000, right? So the excess supply is what? Is the length of this line, right? Right? Everyone agree? So this is excess demand or shortage, and this is excess supply. Right? Everyone agree? Okay. Now, so remember I said about what happens when you open the door. One thing goes out and the other thing comes in, right? So we say there's like a force pushing this air out and pulling that air in or something like that. There's a kind of force, right? Now, if the market is not a free market, that's like having the door shut. What I mean by that is, like a free market might be the stock exchange. That's basically a free market, hopefully. But we learn every day that it's really dishonest and not free. But anyway, it's supposed to be a free market. So if it is a free market, that's like the door is open. You'll see what I mean in a minute. Whereas maybe if we take a situation where prices can't change easily, that's like the door being shut. So if prices can't change easily, then even if there's a big demand, the price won't change. Because it's like, suppose you go to a department store. The department store, they fix the price for the whole year. They don't, like, especially a Japanese department store. So they'll say the price is this, and they're not going to change it no matter what. The price is set at the beginning of the year, and that's it. Maybe they'll have a sale at the end of the year. Even then, they don't discount it much. Whereas if you go to the United States, they have discounts. They easily change the price. But in Japan, they don't do it almost never. So that's not like a free market situation, or that's not where the price is changing easily. Okay? So even if a lot of people want it, they're not going to raise the price, and even if nobody wants it, they're not going to lower the price. Okay? So the price doesn't change then. But if you go to the stock exchange, that's a much better example of a free market. That's a much better example of like when you open the door. So when you open the door, things start moving, right? And in a free market, things start moving. What do I mean by things start moving? Well, if the price is here really high, what did we say? Did we say there was excess demand or excess supply? There was excess supply, right? So what happens when there's too much supply? What happens to the price when there's too much supply? Well, economists will say, I don't know if I say it, but economists will say, what happens in a free market? What happens to the price if you have a whole lot of supply, excess supply? The price will begin to fall. And that will happen, I guess I do agree, that will happen in the stock market. Okay? So, the price is pushed that way, we say, like by a market force. Like there's some market force there pushing it, if you want to think of it that way. On the other hand, suppose the price is really low. Okay? Now, do we say there's excess supply or excess demand? Excess supply or excess demand? Here, low price. Excess demand, right? Everybody wants it because it's a really low price, right? So now what's going to happen to the price? A lot of demand and a shortage of the product. What's going to happen to the price? It's going to get higher, right? The sellers are going to raise the price. So we can say there's like a force pushing it up, if you want to visualize it that way. Okay? Everyone understand? So when the price is low, there's a force pushing it up. In a free market, not in a department store in Japan, right? But in a free market. Okay? How about here? When the price is high, what happens to the price? There's a force pushing it down. How about if the price is here? Let's call it P3. Now what? That's here. What happens? Still, there's a force pushing it down, right? Right? Because there's excess supply. It's too many goods available, right? And what about if it's at P2? Then the price will go up, right? And so on, right? We can say this over and over again, right? You can do this at different prices. Now, is there any place where the price doesn't have a force on it? Is there any place where the price won't have a force? So here it has a force pushing it down. Here it has a force pushing it up. Is there any place where it won't have a force? At the intersection, right? Here. Why isn't there a force there? There's not excess demand. There's not excess supply. So, there's no force on it. Right? Okay? So, then it won't move, supposedly. Unless things change. Then it won't move. Okay? So even in a free market, it won't move when it gets to that price. Okay? So that's called, when the temperature is hot or cold here and hot outside, and then it moves out, moves in. We say it reaches a steady temperature. What do we call that? The equilibrium temperature. And here, we call this the equilibrium price. Okay? The equilibrium price. And this would be called the equilibrium quantity. Okay? So what does the equilibrium quantity mean? It's the quantity that you can sell when the price reaches the equilibrium price. Okay? Does this make sense? Okay? So this is called supply and demand. The law of supply and demand. Okay? This is called the law of supply and demand. Okay, any questions about that? Okay, now, we already agreed that a demand curve should be downward sloping. And the supply curve should be upward sloping. Unless we're in some weird situation, right? But generally speaking, we expect that. So we won't think that we're in some weird situation. So, so let's try and do this problem. What does it say? The demand, so what are we talking about? Demand. So is that the supplier or the consumer? The consumer, right? The demand for monorail service, everybody know what monorail service means? Kind of train, right? In a city can be approximated by this function. Do you see that? Okay, so this is Q as a function of P, right? Which is in our graph? Which did I make the y-axis? Q or P? In my graphs, what was the y-axis? Q or P? Q, right? So this is kind of this matches that basically. So Q is a function of P, like y is a function of x, right? Okay? And here's the function. So let's change it to y and x just to visualize it like that. So what does it say? Y equals what? 51 x to the minus 0.76, right? Right? That's the function, right? Okay. So that's the demand function. Now, first of all, we expect that the demand function should be downward sloping, right? So I want to make sure that this is like that. I want to check, is it really downward sloping? So how can so we have to think about it. So what's the function again? Oh, here it is. Y, I'll just do it with y. With x. 51 x to the negative 0.76. So, is it 0.76 or, okay, let me change it to 0.75 just because the numbers work out better. Okay? Or do I have to? No, maybe I don't need to do that, but let me just do it. Okay, so let's rewrite that like this. 51, 1 over x to the 0.75. Okay? 0.75, 0.76, something. Okay? Alright, now, okay, does everyone agree with that? Now, x, just to review, that means x to the 0.75 means x to the 3/4, right? And that means that, right? You know that, right? I hope. Okay, so anyway, my only question is, as x gets bigger, what happens to this? It also gets bigger, and maybe this helps to look at this. So as x gets bigger, you go 5, 6, 7, 8, 9, 10, 11, 12. As x increases, what happens to this? So you cube it, and then you take the 4th root, it's still getting bigger, right? So if x starts out at 10, you cube 10 and take the 4th root, you get something. If x goes to 100, you cube 100 and take the 4th root. It's obviously bigger than when you got 10, when you put in 10, right? Does everyone agree? So as x increases, so does this, so does this, so does this, right? So as x increases, what happens to this? If the bottom is getting bigger, then the whole thing is getting smaller, right? So that means that this function, is it increasing or decreasing? Decreasing, okay. So at least it fits our model of a demand curve, right? Because we said it has to be a decreasing function. Okay? So it's okay in that sense. All right. So, then we have to decide which of these is the best choice. So is this a good choice for this curve? Well, I hope not, because it's not even decreasing. So I hope it's not a demand curve, right? Because we already argued that except for in really weird circumstances, demand curve should be decreasing, and this is not, right? So this better not be it, right? How about this one? Better not be it, right? Same thing, it's not decreasing. So then we only have 2 choices left. This one and this one. So this one, obviously they're trying to draw what kind of object? Obviously they're trying to draw a straight line. And this one, obviously they're not trying to draw a straight line, right? So then we have to decide which is it. Is it this one or this one? Well, do you think this is a straight line? No. It's not a straight line, right? You know the graph of a straight line, and you know the equation of a straight line, right? So you should be pretty confident this is definitely not going to be a straight line. Okay? So therefore it's not this one, so it should be this one. Okay? Does everyone understand? Any questions about that? Okay. So, okay. All right, let's go on. What is the result on demand if the cost per ride increases from $3.50 to $4.50? Can you read that? No. Can you read it now? What is the demand if the cost per ride is increased from $3.50 to $4.50? So what's increasing or decreasing here? The price, right? That's the price, right? There's a price for this particular thing, right? This thing is a monorail train, so the price of it means, the cost for riding on it, right? That's the price. So they're saying, what happens if the cost per ride increases? In other words, if P increases. So immediately, you should think, what's going to happen? That it's going to decrease, that the demand should decrease. Now, let's see their answers. The result of the cost increase has no effect on the number of riders per day. That's one choice. The result of the cost increase results in a drop of riders by about this. The result of the cost increase results in an increase of riders by about this. Without doing any calculations, which answer do you hope it is? The middle one, right? You want it to be a drop. Now maybe we have to actually do a calculation, right? But if it's anything but the middle one, we'll say something's wrong, right? Okay, now we could do the calculation. What would the calculation, how would we do the calculation? How would we do it? So we put in 350 into P, and we'd get a Q, right? Right? That would tell you when the price is $3.50, what is the quantity demanded, and then we put in 450, and we hope that we'll get a lower quantity demanded, but anyway, we'll calculate that Q, and then we can subtract the two and find out what the difference was. Okay, but I wouldn't even bother to do that. I would just choose this one. Okay, because it has to be that one. Okay, any questions about this? Okay, so this is called, what is this called again? Supply and demand. Supply and demand. Okay, here's another example. The demand for your handmade skate... Oh, now I know what I want to say. Okay, I want to make a comment about this situation. About any of the things that, any of the graphs that I showed you here. Or especially the demand graphs. Now suppose you're a company and you make Rolex watches. So you trying to figure out how much you should sell them for, right? You know that if you sell them for more, basically you're going to sell less, and so on, right? You know that. Now if you knew the demand curve, that would be very helpful. What does it mean to know the demand curve? It means you know that at any particular price, how many you could sell, right? That's what it would mean to know the demand curve, right? So you'd say, well, if the price was here, I know I could sell this many. If the price was here, I know I could sell this many. If the price was here, I could sell this many, right? That's what it would mean to know the demand curve, right? How many companies do you think know their demand curves? How many companies know their demand curves perfectly? No one, right? How can you know how many you can sell? Right? I guess you could know by actually changing the price and seeing, but I mean, you can't do that, right? You can't know your demand curve. Right? Do you understand? So how come they gave us this curve here? They said, here's the demand curve. How come they gave us that? Is that realistic to know that formula? Is that realistic that we would know this formula? No. Right? You're never going to know. And it's never going to be such a simple formula like this, right? Are you ever going to get a formula, like basically as simple as this, that's going to tell you what the demand is at every price? You think it's ever going to work out to something as simple as this? No, there's a million different factors, right? In terms of whether somebody's going to buy your watch or not, right? It's not just dependent on the price. It depends on their income and whether they had a good day today or not, and right, lots of different things, right? Is it ever going to be such a nice little function, simple function like that? No, of course not. Okay? So, what is this? This is just a guess, right? This is just a guess, or we call it just a model. Okay, do you understand? It's not the real thing. So that's what next topic I want to talk about is, what do we mean by a model? So if I say the word model, I think that one of two things will occur to you in your brain. You'll think of one of two things. So one is you might think of like a runway with people wearing fancy clothes. Right? That's one possibility. And the other one is like an airplane model, right? Like you take a little model airplane, and kids like to play with it, right? Or something like that, right? That's also a model, right? But I'm talking about that kind of model. Okay? So why do we call that little airplane a model? Why do we call it a model airplane? What? It's an example, right? But an example of what? Okay, but I mean, how about if you go to Oita Airport and you get on the plane, that's also an example of a plane, right? So what do you mean example? Let's be a little more clear than just example, because Oita, when you go to Oita Airport and you get on a plane, you can say that's an example of a plane. So say something a little more than just example. What's the difference? Why do we call that toy that a kid plays with a model airplane? Why do we call it a model airplane? What? Small scale. Okay. Can anybody else say it in another way?
Small and simple.
Hmm?
Small and simple.
Small example?
Simple.
Simple. Oh yeah, right. Simple, right. Okay, again, another one? Or, okay, so it's, what he said, small scale, she said simple. What we're basically saying though, is it's not the real thing, right? It's simpler than the real thing, right? It has, so, and what's the difference between a model and the real thing? A model has some of the characteristics of the real thing, but not all of them. If it had all of the characteristics of the real thing, it would be the real thing. Right? It would be the plane that you could get on and fly to Tokyo. Right? But a model is different than that. Right? So it has some aspects of the real thing, but not all of them. So it might be smaller, or it might be made out of paper, or it might be something else, right? It doesn't have all of the characteristics of the real thing, but it has some. So why, okay, so think about an architect. Do you know what an architect is? Architect, they build houses, they build buildings. Okay, so suppose you want to build an expensive house, like you're going to build a $2 million house, and you're going to make it according to, you have some design that you want it to look like, or some, you want it to be special, right? So you're not just going to go and say, to some company, just build me this house. You're going to hire an architect and have them build something according to what you want, right? So the architect's going to go and meet you and talk to you for about 5 hours, and then they're going to get the idea of what you want, and then they're going to go home, and about 3 weeks later they'll come back with a model of the house, right? And they're going to come back and show it to you. And you're going to say, oh, that's good, yeah. But then, obviously what's going to happen is you're going to see something there, and you say, no, I don't want it to be like that. Can you move the door over here? Can you do this? Can you do that? Right? You're going to, first of all, they might have misinterpreted what you wanted, and even if they didn't misinterpret what you wanted, when you see the model, you're going to get some new ideas, and you're going to change your mind, right? And so you're going to change. And so they'll go back and do something else, right? Okay? So why did they build the model? What? I'm sorry, what? Prediction? Uh-huh. Predicting, yeah, okay. Or, yeah, because they don't want to build the whole house and then have you say, no, can you move the door over here, right? That would be horrible, right? So they want to start with something which is just a model, which has some of the aspects of it, but not the whole thing. Okay? So that's what we use models for, right? Often, right? And kids like to play with the model. We can't give them the real airplane, but we can give them a model, right? So it's much cheaper. So, okay, so what do we mean by a model of the economy? Well, we don't really mean like trying to build, a picture of the whole world or something like that. Like little houses on a piece of paper. No, we don't mean that, right? When economists talk of a model of the economy, they mean something like what we have here. It's a relationship, maybe this is a model of demand, okay? They mean it's a relationship between things that is approximately true, but not really true. Just like a model house is not the real house, right? So this is a model of the relationship between demand and price, okay? This is this is a model. It's not the real thing. Do you really believe that if you know this price, that you can say exactly how much quantity is going to be demanded? No, of course you don't believe that, right? You wouldn't bet your money on that, right? But you can use this maybe, maybe not, but maybe you could use this as an approximation for what, or as a guess for what the quantity demanded will be if the price is this, right? So if the price is 10, maybe we could say, okay, so this is not we don't expect this to be perfect. You don't expect that you get such a simple equation that will really say how demand will be when we know the price, right? You wouldn't expect that, right? It's just not going to be simple like that in reality. Okay? So this is called a model also. Okay? This is a model of what? Of the relationship between Q and P. Okay? Or even in physics, you'll write an equation. Now, if I write an equation for the way a rocket's going to move, it's really only a model. Why do I say it's really only a model? Because there's so many other variables that are going to affect the way that rocket moves, like the temperature today, the pressure, of the air pressure, and millions of how clean the air is could even affect it, right? We can't write a perfect equation for how a rocket's going to fly, but we can get a pretty good, in terms of, in the situation of a rocket, we can get a very good model for it, very, very accurate. But it's not perfectly accurate, right? No model, no mathematical model is going to be a perfect representation of the real world, right? It's just not going to happen, right? Nobody's going to get that. Even, we write these wonderful physicists do all this stuff, but yeah, they say, under perfect conditions, it'll work or something, right? But it doesn't hold completely ever, right? And it's much worse when we're talking about economics, right? It's much, much harder. It's just that you'll never get you'll never even say it's very accurate. I mean, we do say it's very accurate, but it's never nearly as accurate as like a physics equation is. And that's not even completely accurate. Okay? So when you're talking about economic models, they're just guesses. They're just pictures, right? But it doesn't mean we don't want to use them. We don't want to generate them. We don't want to get them. Because it's better than nothing, usually. Not always. It can be worse than nothing because it could lead you in the wrong direction. Okay? But hopefully it's better than nothing. And people will do it all the time, make these models. And economists, will write PhD dissertations and journal papers and all this stuff saying how to come up with a good model. But you never can believe it completely. Never. Right? So they're all just guesses. Okay? So you have to keep that in mind. Okay? So, but anyway, when we talk about an economic model or a mathematical model of something, it means basically it's an equation. It's not a model of an airplane, which is a physical thing. It's not a model of a house, which is a physical thing. When we're talking about a model of an economy, or the model of something, a mathematical model of something, it's an equation, or it might be a couple equations, or a series of equations, or a bunch of equations. But basically, it's equations relating variables. What are the variables that we're relating here? P, which is what? Price, and the other variable is Q. So this is an equation relating these two variables, relating the quantity to the price. Okay, and generally we're going to have equations like that. Maybe it won't be as complicated as this one. Maybe we'll have just a linear equation. This is a fairly complicated equation. Might just have a linear equation. But anyway, it's going to be an equation relating some variables, and we'll call that a model for whatever it is that we're talking about. Okay? So we talk about mathematical models. Okay, any questions about this? Okay, so here's a different mathematical model. and this is a different one. Now this one is for sales. This one is for demand, and this one is for supply. Okay, so those are different aspects of some economic situation, right? Demand is one aspect of an economic situation, and supply is another aspect of an economic situation. So we have a model for demand, this one. Okay? So one thing is, I hope that it's downward sloping, right? I hope that it's downward sloping, right? Otherwise, I think it's a very bad model. Okay? Is this downward sloping? Is that downward sloping? What's the slope of this equation? -6, so it's downward sloping, right? So at least it's downward sloping, right? And it's demand, so we hope that it is downward sloping. And is this linear? Yeah, this is linear. So that's basically as simple as we can get. This is a linear model for demand. Okay, this is a linear model for demand. Now, do you think it's true? No, it's not true, right? It's not going to be perfectly match reality, right? It doesn't match reality. It can't match reality. It's not going to be a simple straight line, right? Okay, but we can use it as a guess, as a model. Okay, does everyone understand the concept I'm talking about? Mathematical model is here. Okay, then we have also this one for supply. What is the slope of this one, positive or negative? Positive. What is the slope of it? 4, right? That's positive, right? Okay, so this is supply, it's increasing. This is demand, it's decreasing. They're asking for the equilibrium price. Is that going to be hard to find or easy to find in this problem? Relatively easy, because why? This is a line, and this is a line. So hopefully, you can find the intersection of two lines. That's not very hard, right? You're supposed to know how to do that. So you should be able to find the equilibrium price in this particular problem without too much difficulty. Okay? You just have to find the intersection of those 2 points, those 2 lines. And what does it say? Okay, let's read it. What price should you sell your skateboards? This is about skateboards. So that what? What does it say? There is neither a shortage or a surplus. What does that mean? I mean the equilibrium price, right? There's no shortage and there's no surplus, right? Because over here, there's a shortage, right? The demand is high and the supply is low. That's a shortage. And over here, there's a, what do they call it again? A surplus. Over here, there's a surplus. Too much available and no demand. So we want, when there's not any surplus and there's not any shortage, that's here. That's the equilibrium price, right? So you have, but the situation is not these curved lines, but rather it's a straight line and a straight line. So you should be able to find the intersection of 2 straight lines. So I'll assume that you can do that. Okay? All right. And what else do we have here? This is more like the same stuff they keep talking about. Surpluses and shortages. More stuff like this. More, okay. Oh, now, one last thing. And that is here. Now, how can we get how can we figure out what the demand curve is if we know, wait, do they do that here? No, let's look at this one, sorry, let's look at this one. Okay, this is another kind of problem. Let's look at it. We only have a few minutes left. Let's do it quickly, because this is a homework problem. Okay, here we have a table that tells us the spending of all the states in the United States for different years. So 0 means, what does 0 mean? Represents the year 1990. So what does 2 mean? 1992. What does 4 mean? 1994, and so on, right? Okay, so how much did the states spend in 1990? $16 billion. How much did they spend in 1992? 18, 22, 28, 30, right? Okay, what they're asking for is which of these functions is the best fit for this data. So what you see what they're trying to do is they're trying to get a model for spending. But we know that the model is only going to be an approximation to the reality, right? It's not going to be as simple as any of these equations, right? But they're asking you which one is the best model. Now, what do they mean by the best? Well, let's see if they have something. An example here. Don't we have any examples where we have an answer? No. Okay, I know. Let's go to read it. Okay, so here is where he discusses functions and models like we just talked about. And then let's keep going. So you can read about that in his text. This is all the stuff that we talked about. Here you can see supply and demand, right? And equilibrium point. Supply, demand, right? More. Okay, here. Let's look at this example. Quickly, quiet. Here's another example. Okay, here we have sales of Nike over time. And then they ask you, which one of these is the best model for this data? You understand? So let's think about how they do it. So hold on. What they do is, they check each model when t equals 0, 1, 2, 3, 4, 5, and for the linear model they get these numbers. Here's the actual sales here. This is reality here. And then this is the linear model, and this is the quadratic model, and this is the exponential model, and this is called the logistic model. Okay, you understand? So now you still, even with this, how do you know which one is better? Which is the better model? Is linear, is quadratic, is exponential, is logistic? So it's hard to see that, right? So one thing they suggest is you draw a picture. So that might help you. So if they draw the picture, here's the linear. So the red X's are what? What do the red X's stand for? That's the real sales of Nike, right? And what's this line mean? That's a linear model. That's the linear model that they suggested. And then what's this? This is another model. This is the quadratic model. But again, the red X's are what? The actual data, right? And then red X's here are the actual data, and the red X's here are the actual data. Now, just looking at this, it's hard. We may not all agree on which is better, but I suppose we might actually. In fact, which one? Let's see. Do we all agree or not? Which one do you think is best? The top right, top left, bottom left, bottom right. Which one? How many people think this is best? How many people think this is best? Okay, how many people think this is best? How many people think this is best? Okay, well, it's about half and half for this one and this one, and they say that this one is better. Okay, but how do they know? Because we just said that by looking at it, we don't agree. So how can we decide which one is better? So what we do is we take the distance of each x from the corresponding point, and do that here also. But we have to be a little bit careful because we take those distances here, 1, 2, 3, 4, 5, 6 distances. If you just sum those distances up, you might get 0. Because some of them might be negative and some of them might be positive, might get cancellation. And if you get 0 for both of them, it doesn't tell you which one is better. Right? So what you do instead is do something like this. You actually don't do this one, but what you could do is take the absolute value of each of these numbers. So then you get rid of the negative sign, so you won't get that cancellation. Actually, we do something else. We square it and take the square root. So instead of taking the absolute value, you square the number and then take the square root of it. That does basically the same thing as taking the absolute value. It gets rid of the negative sign. For some reason that works better for other things. Anyway, so if you do that, then we can decide which is the best model. Okay, so visually doing it is not so great because we see that different people can see it differently. Okay? Anyway, so that's the kind of thing we're doing here. So they might ask you to do that in some of the homework problems. Okay? Okay, so we tried to record this, so in case you want to review it, I'm going to post this later. You can look at it later. Okay? That's all. Okay, for those of you, anybody who came in late, I said that we will have a cancellation of class